So today I'm going to solve the two-sum problem. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So we are going to have an input that's taking an integer array of nums and a variable of type integer target. I am going to ask clarifying questions. Can the input array be null or empty? If the array is null or empty, return nulls or empty. That sounds like a reasonable solution. Null or empty or null, right? So can this array contain positive and negative integer? Both? Probably, I think. So what about duplicate elements? Can this array have any duplicate elements? I want to title this questions. No duplicate elements because the problem say each input would have exactly one solution. We might just need to return the element with the lowest index. That's perfect. So let's have some test cases. And so if the input is null or empty, we would return null or empty. If we have 0, 1, 2, and the target is probably maybe 10. We are looking for two numbers that add up to 10 in the array. Apparently, there's no numbers in this array that can be added up to 10. In this case, what do we want to return? So I think we're gonna just return an empty array of integer, empty array, right? And so we have another case when we have only one element, maybe 4, for example, and then we need to return 4. So what do we do in this case? I think we would just throw an error, or return empty, or return empty array, right? So we need to have at least two elements in the arrays, and then if the target is okay, so this is a target. If the target is 9, in this case, we would return 0 and 1. And then, so if we have 1, 3, 4, 9, 6. No, it cannot be 6. 5. And we need to find two elements that add up to 9. Apparently, we're gonna return indexes of 0, 1, 2, 3. 0, 1, 2. Okay, we need to return indexes 2, that's where 4 is, and then 4, that's where 5 is. One solution to this problem is to loop through the array one by one elements, and for each element, we would loop through the rest of the elements in the array and add the second element to the current elements, and then check if that sum is equal to 9. If the sum is equal to 9, we would return the indexes of that elements. However, this solution would take big O of n squared, with n is the total number of elements in the input array. Solution, brute force. N number in the array, n number in the array. And for each element, we have, in worst case scenario, we have to loop through n minus 1 element n times n minus 1, which is equal to n to the power of 2 plus n. And because it's a big O, in big O, we only care about the bigger number. So we would have big O of n squared. We can do better than this. There is another solution where we utilize hash map. So as we loop through the first elements as we go to an element in the array, we can find a complement of the current elements that would add up to 9. So for example, the complements of 1 would be 8. And then as we go through the array, if we encounter 8, we would return the indexes that corresponding with the key value 8. So for example, we take 1 and then we would have the 9 minus 1 equal 8. We would have 8 as a key value and the value is 1. Value would be the indexes of the array. So as we loop to 3, we check if 3 is in the map. We don't see it's in the map, so we find the complements of 3, which is 6. And then we add 1 indexes of 3 into the hash map. And then we go to 4. 4 is not in the map. We find the complements for 4, which is 5. And then we add 2 as value. Then we go to 0. Complement of 0 is 9 and index 3. And then we go to 5. 5 is in the hash map. Ta-da, ta-da! And then 5 is indexes 4. So we would return 4 and 2. Because we can return the answer in any order. So 4 and 2 will be 5. It doesn't have to be 2 and 4. Okay, so this solution would be faster than big O of n squared because we utilize the use of hash map. We just need to loop through the input array 1. And if n is the number of elements in the array, it would take linear time, big O of n. And the space complexity would be could be big O of n as well, as n is the number of elements in the array. So for the brute force solution, space complexity is smaller. It's just a constant because we don't utilize any additional elements. Let's code this up. So if num equal null or num, if the array is null or array is empty, num dot length smaller than 2, I think we would just return null. And then otherwise we would initialize an answer array of, let's name is indexes, equal new in with length 2. This array has length 2. And then we need to utilize a hash map of type integer. I'm just gonna say map, initialize new hash map. And then we would look through the input array. If we have to check if the current elements in the array is in the hash map. Right, so if map contains key num I, we would have to put indices 0 equal I and indexes 1 equal map.get num I. If the map doesn't contain if the map doesn't contain the current elements in the array, we would find the complement equal target minus num I, and then we would update the map, put num I. Okay, so we need to put in a complement instead. Complements and indexes. And then at the end, we would return indexes. Let's test this code that I just wrote. So if the input is empty or null, we return null. If the input has length smaller than 2, I also return nulls. And then I initialize a new array indexes of integer with length 2 and a new hash map of type integer as key and integer as value. And then I loop through the input arrays of rate, and then I check if the map has a key. Let's look at a real example. Return indexes. So let's look at these examples. For example, if I look through the indexes array, so the first elements would be 1. Map doesn't contain 1, so I find the complement of 1 to be 8, and I would update the map to have 8 and 0, right? Indexes would be 0. Num I would be 1. And then we increment to index 1. Num I would be 3. Complement would be 6. And map would update 6 and 1, right? And then we have the next indexes is 2, and the next element is 4. 4 is not in the map either, so we find the complements of 5, and then we update 5 and 2. We go to next index is 3, and we go through. We got the next index is 0. The next element we got the next element is 0. 0 is not in the map either, so we would get the complements to be 9. We update the map with with a key value of 9 and a value of 3. Right, right, and then the next indexes is 4, and the next element is 5. And we found 5 in the hash map. Hooray, hooray, hooray! We update the indexes to be 4. And yay, is right. And we would submit this code. Accepted. Thank you for watching. I hope that helps.